dear students, today I am going to discuss regarding the relationship between AC and MC. Okay, yesterday I have already explained that the relationship between AVC and MC. Okay, so here I have taken the output, that is 0, 1, 2, 3, 4, 5 and so on. So at the 0 level of output, TC is 12. So everybody knows that TC is equal to TVC plus TFC. So TFC, that is the fixed cost, total fixed cost. So either the production increase or decrease or it is constant, the value of TFC will remain at all level of output. So here, if the TVC is 0, and TFC is suppose 12, then the value of TC is equal to 12. So there is an exceptional point that even though the output will be 0, the TC will be something, and here I have taken 12. Or you can say at 0 level of output, TFC is always equals to TC. Is it clear? But as soon as we increase the production, our variable cost, total variable cost starts to increase. So suppose if we are going to produce 1 unit of the commodity, our total variable cost is 6. So that is the 6 plus 12, our total cost has become 18. Now, if another one more output is being produced, so what will happen? The total variable cost increases from 6 to 10. So 10 plus 12, that is the total fixed cost, our total cost has become 22, and so on. It will continue. Now I have to calculate AC. So we know that AC is equal to TC divided by output. Is it clear? So it is a formula because AC indicates the per unit cost of production. AC, once again, AC indicates the per unit cost of production, and per unit cost of production can be calculated with the help of TC divided by output. So here, if the TC is 18, so 18 divided by 1 is equal to 18, 22 divided by 2 is equal to 11, 27 divided by 3 is equal to 9, 36 divided by 4 is equal to 9, and 50 divided by 5 is equal to 10. So what you find here? You find that here initially the AC is continuously declining. 18, after that 11, after that 9. But when it becomes 9, for a certain period of time, means only for 1 unit of production, it is constant. That's why that is 9 and 9. After that, AC starts to increase, and if once the AC starts to increase, it will never decrease unless there is no change in technology. So it will continuously increase. So what will be the shape of AC? So here we will find that is the suppose 18, next 11, next 9, after that 10. So it will make the U shape in this way. So we will discuss how it works. Now come to the marginal cost. So many times I told you marginal cost is equal to change in TVC. So here delta indicates that is the change. What changes takes place as the output increases. Okay, so here I have already taken the TVC, that is the 6, 10, 15, 24, 35 and so on. So the marginal cost will be, that is the 6, the difference between first unit to second unit, the total variable cost is 4, that's why the marginal cost is 4. second to third, that is the 10 to 15. So here again it is the 5. Next 15 to 24, that is the 9, and 24 to 35, that is 11. So on the basis of this schedule, you may write in this part. When AC falls, look here, when AC falls, clear, 18 to 11. When AC falls, MC falls at a faster rate. So here, that is the 6 and 4. So you find that MC is falling at a faster rate. That's why MC is less than AC. Clear? Next, when AC is falling, so either the AC is falling or it is the constant, you find that the MC starts to rise 4 to 5, 5 to 9. Okay? So AC still it is falling, but MC starts to rise. Now third point, that is the when AC is the minimum and the AC is the minimum at 9. Okay? So here MC is also 9, so it indicates when AC is the minimum, the MC intersect AC, so here AC is equals to MC. Okay, so here also MC is 9 and AC is also 9. Now come to the fourth point, when AC starts to rise from here, MC rises at a faster rate. So after this point, if output increases, MC, that is the most important, increases at a faster rate. So MC becomes greater than AC because the value of MC is here 11 and here the value is 10. Is it clear? Now come to the diagrammatical presentation. On the y-axis, we will take the AC and MC, and on the x-axis, we will take, that is the output. So this is the x-axis, this is our y-axis, it is our output. Is it clear? Now the value of AC, that is the maximum, here 18. So 2, 4, 6, 8, 10, 12, 14, 16 and 18. Is it clear? Output, that is the 0, 1, 2, 3, 4, 5, 6 and so on. Clear? So first of all we will draw the AC. When the output is 1, the value of AC is 18. So put a point here. Now when we produce one more unit, means second unit, the AC starts to fall and it becomes, that is the 11. Okay? Now comes the third, that is it becomes the 9. Is it clear? So suppose this is 9, on the fourth again it is the 9 and on the fifth it becomes 10. So this will be the shape of the AC. So AC makes U-shape. Clear? The shape of the AC will be U-shape. Now come to the MC. So when output is 1, the value of MC is, that is only 6. Is it clear? When we produce the second unit, the value of MC is 4. When we produce the third unit, the value of MC is 5. When we produce the fourth unit, the value of MC is 9. And when we produce fifth unit, the value of MC is, that is 11. So here we find that MC is also U-shape. But what you find? This is the minimum point of MC, and after that MC is continuously starts to increase, but AC is continuously falling. Is it clear? This is the point where MC is equals to AC, and when the MC will becomes equals to AC, after that if we increase the output, MC increases at a faster rate. That's why the MC curve is above the AC curve, and here we can say MC is greater than AC after this point, and below this point MC is less than AC. Okay? So the same thing you will follow whatever I had written on the board. Okay? Thank you. So now come to the AVC. So in this diagram you find that AC and MC both are given. Now come to the AVC. Okay? So as we know that AVC is equal to TVC divided by output. Is it clear? So TVC divided by output, it indicates that AVC is the per unit variable cost. So per unit variable cost means if we increase one more unit of output, what will be the average value of the second unit, average value of third unit, average value of fourth and fifth and so on. Is it clear? So here I have taken the TVC, that is the 6, 10, 15, 24, 35. So what will be the value of ABC? 6 divided by 1 because output is 1. So ABC it will be the 6. Now when we produce the second unit, the total variable cost is 10. So average variable cost is 5. Now if we produce the third unit, the total variable cost is 15 and ABC is 5. And in this way we find that if we move towards the fourth unit of output, the total variable cost is 24 and the average variable cost is 16. So what you find? You find that initially average variable cost is decreasing, after that it becomes constant, and after that it starts to rise. So why it happens? Everybody knows that the law of variable proportion applies. That is the increasing return here that is going on, and that's why the AVC is declining, and here diminishing returns starts to happen in the production, and that's why the AVC also starts to increase. So now put the value of AVC. So AVC value for the first unit, that is the 6. Again for the second unit, that is the 5. So suppose this is the 5. Again on the third unit it is the 5. Next, that is the 6. Next, that is the 7. Sorry, third that is the 5. So here that is the 5. It is constant. Is it clear? It is the constant 5. Next, fourth, that is the 6. Next, that is the 7. Fifth, that is the 7. So this is our AVC. Is it clear? So here you find that this is the point where AVC is equals to MC, because this is our MC line. Clear? And this is the point where MC is less than AVC, or MC is less than AVC. After that, MC is greater than AVC. The same thing will happen as the output increases. AVC starts to decline due to law of variable proportion. A time will come when MC will becomes equals to ABC, and after that if we increases the output, MC increases at a faster rate, but this is the minimum point of AVC. So when MC is equal to AVC, it means AVC is at minimum point. So reaching at the minimum point, AVC starts to increase and it will move towards the AC. Okay? Thank you.